Here we present our work, Make Your Brief Stroke Real and Stereoscopic, 3D-Aware Simplified Sketch to Portrait Generation. Sketching is a wonderful activity that can be enjoyed by people of all ages, which can be a valuable tool for both educational and creative purposes. However, there is often a significant gap between the casual sketches that many people create and realistic portraits. In this paper, we study the problem of creating stereoscopic portraits with high-quality 3D geometry from simple sketches. With the development of generative models, researchers formulate this task as an image translation process. Nevertheless, many previous methods are basically 2D-based, which means that their generated faces are constrained to the exact views as the sketches are drawn. Another slew of studies explore semantic 3D-aware image synthesis, but facial details such as wrinkles and hairstyles are lost in this representation. Unlike them, our approach mainly focuses on building a user-friendly real-time interactive system even for non-artists by taking only hand-drawn sketches as input, which are much rougher and more abstract signals than the semantic mask used in IDE 3D. To this end, we propose Stereoscopic Simplified Sketch-to-Portrait (SSSP) system. Given a simple contour, our system firstly convert it to a delicate sketch. Realistic portraits with consistent 3D geometry can be rendered by our system that aligned perfectly with the sketch. The contours and the sketches can both be modified by users for editable interactions. Below we showcase some sample results. Note that our system receives very simple contours as inputs, and iteratively refine it to a 3D geometric-aware portrait. Here is the overall pipeline of our proposed SSSP system. The overall framework consists of three major parts. The first part is the contour-to-sketch module. At this stage, the user will edit a simplified facial contour and feed it to this module to obtain a predicted detailed sketch via a vector-quantized (VQ) delicate sketch representation. Another part is the sketch-guided 3D-aware portrait generation module, which aims to transfer the predicted delicate sketch to a triplane feature and render it as the final high-fidelity portrait image. Finally, the sketch-aware rendering constraints are proposed to bridge these two components. To further enhance the generation quality, we introduce two extra techniques including region-aware render and symmetric constraint. Feel free to refer to our paper for more details. Below we demonstrate our comparison results with state-of-arts. We first evaluate the generation quality of our method under a fixed-view setting. It can be seen we achieve comparable performance with Pix2Pix HD. We also evaluate our approach on Freeview synthesis. It can be seen that both PSP and Pix2Pix HD suffer from blurry textures under novel views. Here we show the ablation study. Compared with our full model, without RAS tends to render over smooth facial textures on local parts. Without SC, the model fails to reconstruct symmetric images for symmetric 2 sketches. Additional results under various challenging scenarios are demonstrated. We also conduct user study consisting of fixed task and open-ended task sessions. Thank you for your interest.